Good to see you. Welcome aboard. Today we're going to be looking at using the midpoint, specifically looking at a midpoint, congruent, and segment bisectors. So once again, you're going to notice that there's some words up here that we don't necessarily know what they are. Midpoint, we've never really looked at exactly what it is. Congruent, it's kind of funny. Maybe you've heard it. Segment, bisector, we heard of segment, not so much of a bisector in this class. Something that brings up something that we don't talk about very often, but in geometry itself, we're going to learn more new words in this one class than you will in 4 years of high school English. And that's just kind of how the cookie crumbles. There's a lot of things to know. And once you know them, you can use them and apply them, and that's what we're looking for. And so it's exactly what it sounds like. Let's just say out there in the world, we have a line segment. And today I want to call my line segment JK. So I'll call it, hopefully I will call it JK. The midpoint is literally the point in the middle. The point in the middle. So here would be my midpoint. And I'm going to call it M. Point M for middle, for midpoint. So now we would have JMK. So at this point, right now you're thinking, okay, it's in the middle. That means if this JM was 7, that means from M to K would also be 7. What does that mean about JK? It means from J to K would be 14. Sometimes they don't, not all the time, sometimes they don't give us numbers. All we know for sure, the only thing that we actually know for sure is that M is the middle. Now what does that tell us about JM and MK? It tells us that JM, this piece right here from J to M, is literally equal to this piece right here, MK. So JM and MK. Now I said equal, but here I marked the points, not the numbers. And since we're using bars to represent the segments, they are equal, but what we like to call them when we're talking about pieces, physical distances, a physical piece like this piece of paper and this piece of paper, we're looking at what we like to call congruence. Congruence means that two things are the same length, like these two right here. They're the same size, same shape. Congruence literally means same size, same shape. I'm going to write that down because it's that important. So we had congruence, same size, same shape. Congruent, same size, same shape. Same size and same shape. Has to be both. And something that you can remember, pieces are congruent, numbers are equal. Yes. So that's what you're looking at there. So right now we have midpoint. Literally the point in the middle. And congruence, same size and same shape. Congruent, same size and same shape. Segment bisector. Segment bisector is something else that cuts it in half. Something else. It's not a point. So if there's not a point that's going to cut something in half, it's going to be a line, usually a line. So let's take a look. In bisector, so bisections. Bi meaning two, sector meaning sections. So two equal sections. That is important. The fact that they are equal is going to be very important. So let's take a look what a bisector might look like. So if I have a line, K, L, M, and we had line R, O. K to L, this piece right here, K to L, is equal to LM. So KL, this piece KL is congruent to LM. So I could say KL is congruent to LM. What does that mean? That means that R to O is a segment bisector. So in this case, RO is a segment bisector. I'll call this A, B, C, and D. And I say that AB will intersect CD at point F. Now this is not drawn to scale, but I'm going to make a mark here and a mark here. These tick marks mean that this piece from C to F is congruent to F to D. Now I would write CF is congruent to FD. Likewise, I could also say that here I have two tick marks and two tick marks. That means AF is congruent to FB. In this scenario, we have line segment AB bisects CD at point F. We also have line segment CD bisects line segment BA at point F. You can also say that they both intersect each other at point F. Alrighty, so today we're going to look at midpoint and segment bisectors. We're just going to be looking at a couple examples. I believe there's 4 of them. We're just going to be finding the value of x just to get a hold on how all of this works. Okay, so yesterday we spoke about what these things mean. Here, we don't, so this is what we do know. We want to start off with what we know. We know what we're looking for. What else do we know? We know that here, these little marks right there, what do they mean? They mean that these two pieces, DE and EF, are congruent. That's what I know. I know for a fact that DE congruent to EF. We know that much. We know that DE is 12. So what does that make EF? EF is also 12. Pretty simple right here. This is 12. We also know that DE plus EF is equal to DF. So this is 12 plus 12 is equal to DF. So this is 24 is DF. So a couple things happen here. We realized that this E was a midpoint. So DE was 12, EF was also 12. We then said, okay, the segment addition postulate says DE plus EF is equal to the whole thing DF. That was right here. We just substituted those in and said 24. Yes, I understand that some of us could probably do that in our head, and probably pretty quick. But we want to show all of our work. There's more to that as we go a little bit later on. And we are looking at HI is 7, IJ is also 7. What do I think I just gave it away, but what it says is this: HI is 7, IJ is X. We don't know what that is. We do know that I is in the middle because it's a midpoint. It says that HI is congruent to IJ. So HI is congruent to IJ. And we can just substitute 7 is equal to IJ, which is X. So here we have X is equal to 7. Pretty simple problem, pretty straightforward. Here, I like to go. We have another interesting problem. Here we have AB and BC, where B is a midpoint. We have AB is congruent to BC. So we know AB is congruent to BC. Here we have X is equal to X. That doesn't really help us a whole lot. What does help us is that we know that the whole thing, AC, is equal to 30. So we have AB plus BC is equal to AC by the segment addition postulate, and that gives us X plus X is equal to 30. Or 2 X's, because X plus X is 2 X's, is equal to 30. 2 times X is equal to 30, so that means I need to divide by 2, and X is 15. It's a pretty straightforward question here as well, as far as solving that problem. Which brings us to our final problem. Here we have 6x minus 7 and 5x plus 1, given that ZY is a segment bisector of PR. So ZY is a segment bisector. What does that tell us? That tells us that these pieces are equal. I'll write those in blue so maybe you can see them. They are equal. So I know that. Now this doesn't have a point right here, right now, so I'll call it Q. It'll help me out a little bit. And so now I have PQ is equal to QR. So as long as I'm able to set up my equation congruent, I should be able to work it out. So this is your most important step. So here, PQ is 6x minus 7 is equal to 5x plus 1. And from here, all you're doing is just solving the equation. I would subtract 5x from both sides of my equation. That leaves me with x, so 6x minus 5x, so just 1x, minus 7 is equal to 5x minus 5x, 0, so 1. Add 7 to both sides of my equation, and x is equal to 8. Here in this problem, all I'm looking for is what is x. I found x, there it is. So as long as you're able to set up your equation, you'll be able to solve it. And thank you all for being here. Thanks for coming out. Thanks for sharing your brain with us today. See you tomorrow.